Hello, this is Laura, and I'm going to be walking through a question pertaining to mechanics in AP Physics 1. I will focus on forces in motion, and I have broken down the problem into 3 parts, so I'll be going through them one by one. So, a 100 kilogram box rests on a platform of the electrical forklift. Starting from rest at the time t equals 0 seconds, the box is lowered with a downward acceleration of 1.5 meters per second squared. So let's delve into part A. We are asked to find the magnitude of the upward force exerted by the horizontal platform on the box as it is lowered. So of course we want to draw out our components as shown on the slide. So in this case, upward force is actually just the normal force. In most cases, we're used to seeing problems in which the normal force counteracts the gravity and is actually equal to the force of gravity. But in those cases, the object is usually at rest on a flat surface. Since this box rests on an elevated platform, the forces are not equal, so we must subtract the normal force from the force of gravity. So Newton's second law tells us that the net force is the product of mass and acceleration. We can easily solve this with the given information and find our answer to be 150 newtons, as shown on the slide. So let's set our answer equal to the force of gravity minus the normal force. When we do this, we have to keep in mind that Fg equals mg, with g being the acceleration due to gravity and m being the mass of the box. So now we're going to isolate normal force, and our final answer is going to be 830 newtons. Now let's take a look at part B. We're presented with new information at this point. So at time t equals 0, the forklift also begins to move forward with an acceleration of 2.0 meters per second squared while lowering the box. The box does not slip, nor does it tip over. So we are asked to find the frictional force of this box. So if the box does not slip, then the frictional force between the box and the forklift platform must be enough to counteract the forward force that is acting on the box. So this means that we could just set our frictional force equal to the net force or the sum of forces, which, as we all know according to Newton's second law, is F equals ma. So when we sub in, we have to keep in mind that we're inputting the acceleration that's in the forward direction, which is given to us above. So we are going to multiply 100 kilograms, the mass of the box, by the acceleration in the forward direction. When we do this, we get 200 newtons as our answer. Finally, let's take a look at part C. Determine the expression that describes the path of the box, assuming that at time t equals 0 seconds, the box has a horizontal position of x naught equals 0 and a vertical position of y equals 3 meters above the ground with 0 velocity. So our kinematics equations will be coming in handy here. So we will be using the equation that is shown on the slide. So the vertical and horizontal components of motion are independent of one another, so we can find the separate displacements in terms of x and y. So initial velocity is 0, and the initial positions are given to us in the problem. So let's solve everything in terms of t. So for our horizontal component, we will do the math and find that x equals t squared. For our vertical component, we'll find that y equals 3 minus t squared. So now we're going to use substitution to turn this system into one equation, which is expressed as function of x. So when we do this, we will find that our final answer is y equals 3 minus x. Thank you so much for watching.